So now we're going to come upon the realization that there are different types of skeletal muscle fibers that are present in your bundles of muscle. Generally, there are different types of these fibers found in each muscle bundle there is. So let's say, for instance, your biceps will have these three types that we're about to talk about. So there are three major different types, and each type has its own specialized characteristics. And the first of these are the slow oxidative fibers. You may hear them called something else as well, but these are the names we utilize, or at least I utilize. There are the fast oxidative glycolytic fibers, and there are the fast glycolytic fibers. So we'll talk about each, and let's begin with the slow oxidative fibers. They are the smallest in diameter, okay, and least powerful. And their other properties, they appear very dark red because they're going to have tons of myoglobin in them. The name should probably give that away. Oxidative, oxygen requiring, so you would think they're going to have lots of blood vessels to deliver that oxygen necessary, and lots of myoglobin as well. Both of those are going to contribute to the dark red appearance. We're going to be talking about, since they are slow, we're going to be talking about mostly aerobic respiration. That's a process here. They are a slow speed of contraction. We're talking from 100 to 200 milliseconds. And when we get to the fast glycolytic, you'll see the huge difference between the speeds of those different fiber types. But this is pretty darn slow for a skeletal muscle fiber. They are very resistant to fatigue because there is so much oxygen in the area, there is so much myoglobin and blood vessel supply and so forth for oxygen. Also rich in glucose, of course, glycogen. They're capable of sustained contractions, and they're best suited for posture maintenance and for long-term aerobic endurance type activities. So we're talking about a muscle like the soleus, which hopefully you know where that's at now, in the legs. Right, so for, let's say, marathon runners, long-term activities, and the postural muscles of the back, all very critical and require these types of fibers, these slow oxidative fibers. The second type are the quickest type. We'll come back to the middle category so you can kind of see how it relates to the other two, but the fast glycolytic then are going to be the fastest type of fibers. They're adapted for quick responding. They then are subject to very rapid fatigue. They're going to be having tons of enzymes that are going to help them deal with the phosphagen system and with the breakdown of glycogen. They're going to be very poor in energy production because they're quick to react and quick to fatigue. I mean, there's just not a lot of time for the mitochondria to generate lots of ATP and so forth. Okay, the contractions are very fast. Remember, we talked about 100 to 200 milliseconds in the prior slide for the slow oxidative, and here we're talking under 10 milliseconds. That's a pretty darn big difference there. So we're talking about eye muscles. The gastrocnemius has some these types of fibers in them, and the biceps brachii. Think about weightlifting, right? You want to jerk this weight up very quick. You want it to happen in a rapid manner. The in-between types of fibers are called FOG fibers, fast oxidative glycolytic fibers, and they are going to have characteristics that are in between the slow oxidative and the fast glycolytic. So just think about what's in between them, and that pretty much describes the FOG fibers. So they have a fairly dark red appearance. It's not white or pink, and it's not dark red. It's in between those two. They can generate ATP by cellular respiration, but they also can revert to anaerobic fermentation as well. Fairly resistant fatigue, but not as good as slow oxidative, but better than fast glycolytic. And as I already mentioned, they will generate some ATP through anaerobic fermentation. Their speed of contraction somewhere in between the FG fibers and the slow oxidative fibers. And so these are activities you might think about that would require these types of fibers, like walking, maybe some light sprinting and so forth. Let's look at the actual characteristics. You can see in this picture the deep dark red ones are the slow oxidative, whereas the more pinkish hue without the the large amounts of myoglobin in the area are the FG fibers. Now, you have a genetic predisposition. Your ratio of these SO to FG fibers is set at birth. Small amounts can transition between the two. You can have, if you want to be a sprinter, well, you can develop a few more FG fibers. Some of those SOs will convert to FGs. And if you want to be more of a marathoner, well, some of those FGs can convert to SOs, but not a whole big lot of them. It will just be a few. I've heard that there is gene doping that goes on, that there are gene therapy processes where athletes are going in to try to get more directly altered these factors that will change the types of fibers they have. So if they want to be sprinters, they'll get more of their SO fibers converted into FG fibers. Gastrocnemius is mostly FG because you're going to be using it to jump up really quickly, but at the same time, it's going to have some SO fibers in it as well. So that's what I was talking about at the first, is that there is a mixture of these fiber types in each of your muscles. The soleus more likely has SO fibers because of long-term jogging, but still has FG fibers for certain processes that it's going to mediate. All right, so as we talked about, most muscles are a mixture of all three types. The ones that are responsible for posture, for long-term standing and so forth, they're going to have lots of SO fibers. But when you're talking about areas where you need quick movements to happen fairly frequently, you're going to have more FG fibers. And then leg muscles are obviously going to be a mix.